The question: is stainless steel wire better for bassoon reeds than brass wire? This is maddeningly difficult to answer. There are more variables to a bassoon reed than most people realize. These variables all affect each other. For instance, a thicker scrape can work well on a longer blade, but not the other way around. A shorter reed can raise pitch, but it can also increase flexibility of pitch, while flattening the second wire can lower the pitch. So while it may seem more fair or scientific to isolate one variable at a time, this is hardly a fair way of assessing whether a change in one variable is universally good for bassoon reeds, or just good for bassoon reeds that are otherwise made in the exact same style. Of course, we don't play reeds in isolation. So even with keeping things the same, different reeds may work better with different bassoons, bocals, or human mouths. And of course, every piece of cane is different. So what does better even mean? This is chaos. Before I tell you how I even begin to make order out of this chaos, I just want to take a moment to remind you that this is the very nature of reed making. That every teacher or person you have sought advice from on your bassoon reeds, no matter how esteemed or experienced they may be, has gleaned whatever observations they have been able to in a mostly helter-skelter analysis of an infinitely convoluted labyrinth, interwoven by both subjective and objective fibers, peppered with ego and salted with insecurity.
Likewise, they too receive their perverse kernels of knowledge, if it can be called such, from others who similarly trudge through this absurd landscape, regurgitating and atomizing the opaque witch's brew known as bassoon reeds.
So what happens in the laboratories of Lil Ass Kicker's bassoon reeds? Whenever I consider making a change to my reeds, be it the brand of cane I'm using, a new forming method, wire placements, or a profile setting, I will typically make 10 to 20 reeds with whatever change I'm considering, along with an equal amount of reeds in my usual fashion. I will finish each reed to be the best that I can. Then, hiding the markings that note the differences, I will try to play all these reeds and rank them from best to worst. Then, I will look at the markings and try to see if one version tended to rank better than the other. Most changes and experiments do not yield clear results, but rather just a tendency to be more or less successful than my standard methods. But within these tendencies, I try to define as clearly as possible what the difference is. Better response, a wider dynamic range, something about the timbre or intonation. If I am able to define the effect the change had on my reeds, then I can more easily determine if the same change will have a similar effect for someone else. But even if I'm comparing 40 reeds of two different types, it leaves a pretty big blind spot, which is how the reed breaks in and changes over time. So considering this and the fact that I'm nearly out of yellow brass, I decided to run some very specific tests on just two reeds that were already well broken in. Because the beauty of the wires is that they can be changed. I want to be clear that this is not science. Inspired by science, maybe. I do want to be able to make as many objective observations as possible, but I'm also trying to make art, and therefore anything objective is subject to my own subjective judgment. I didn't exactly have a hypothesis going into this, but rather a suspicion that if anything, different types of wires might have an effect on response and timbre. I did not think I would find any clear differences in terms of intonation or projection. So I started by selecting two Lil Ass Kickers from my reed case. I set up a high-quality large capsule condenser microphone, my Neumann U87, and in addition to just playing each reed, recorded several specific pitches across the range of the instrument. I was careful to select both problematic notes and more comfortable resonant pitches as well. I started with the yellow brass wire that was already on each reed, and while I can't say exactly how old the reeds were, they were both very much broken in at this point. But since I was a bit curious how the brass wire in particular may age, I then put brand new yellow brass wires on each reed and repeated the recording process. I was careful never to move my chair or the microphone stand while doing this, but I think it's worth noting that even small movements can affect how sound is recorded. I have to say that I didn't notice much difference in playing the old yellow brass versus the new yellow brass. Maybe I felt a slightly better response from the new yellow brass, but this was probably due to the wires getting some extra attention when I was putting them on and adjusting them just so. After that, I put 22 gauge stainless steel wire on the second wire, leaving yellow brass on the first. Again, I didn't notice much of a change in response. However, I did feel like this required me to flatten the second wire just a tad. Now this can flatten the pitch of a reed, but I actually found a few pitches that had been flat before with all brass wires were more in tune and easier to adjust. So I suppose I'm a little less inclined to attribute this to a nominal wire adjustment. I also noticed this on just one of the two reeds. It's possible that the steel wire helped stabilize the pitch rather than just sort of magically fixing it. That perhaps one reed was just older or slightly more unstable to begin with and therefore found benefit from the steel wire. Next, I swapped out the yellow brass on the first wire so that now both wires were stainless steel. I have to admit, I was kind of hoping this would be the winner. Unlike brass, steel is hypoallergenic, and although I don't personally have a sensitivity to brass, oh, how I feel for those that do. Brass is also sometimes made with lead, and although I always verify with my suppliers that their wire is lead-free, they are often taking the word of their suppliers, who are often overseas. Steel also looks cooler and doesn't tarnish like brass. I was a little surprised and disappointed on both of the reeds that had all stainless steel wires. I found them noticeably stuffier and less responsive. And I wasn't able to fix this with a simple wire adjustment, although I suspect a different scrape may have helped. I also think it'd be worth trying thinner gauges of steel wire if you have a brass allergy. The stainless steel wire was also harder to work with. It was very hard to cut with my reed pliers or even a wire cutters. And it's a bit more slippery than brass, so that when I was tightening them, my pliers would often slip right off the thing. However, both of these problems were easily resolved when I bought a higher grade linesman's pliers that I'll link to in the description. I was also a bit curious about red brass, which I experimented with a long time ago and did not prefer over yellow brass because it's more brittle. I found it annoying to work with. But I'd heard some chatter on the internet that some folks prefer a thinner or looser first wire. Since red brass is softer than yellow brass, I figured it might offer more of a contrast against the steel than yellow. Anywho, when I tried the reeds with red brass on the first wire and stainless steel on the second, I felt like they had become more responsive. Certainly more responsive than when I had steel for both wires. On one of the two reeds, I felt like it was better than the yellow brass as well, but this is hard to say for sure since I was coming from just having played the stuffy stainless steel reeds. Of course, given that I was a little biased against red brass to begin with, I thought this was perhaps quite telling. I also continued to feel like the intonation was less problematic on that one reed when both first and second wires were yellow brass. Dude, what about the third wire? Well, I'm glad you asked. I actually decided months ago, without doing any experiments, to start using stainless steel on my third wire. It just made sense to me to use a wire that doesn't stretch so much since it can't really be tightened, and steel is more rigid and holds its shape better. And of course, I want to keep the butts of my reeds round. And I certainly didn't notice any ill effects when I started doing this. At this point, I felt like there may be a very subtle advantage to having stainless steel on the second wire, and that perhaps red brass yielded better response than yellow on the first. I like that stainless steel doesn't corrode or tarnish, and red brass supposedly does so less than yellow brass. But Scott, what about tone? Well, first of all, tone is a word that people use to describe sound when they don't really know what they're talking about. I'll get into this in a future video, so don't forget to subscribe. But if you're curious about timbre, I was curious too. What constitutes good timbre is very subjective. It's a matter of opinion, and that opinion can easily change based on context or time of day. Our preferences for timbre often depend on our expectations of how a sound meets or surprises those expectations. However, timbre itself is not a subjective phenomenon. It's important to understand what it actually is. To help me analyze as well as explain what timbre is, I'm using a program called Voce Vista Video Pro. I don't work for them. I'm obviously still using their free trial, but it's a really great program for demonstrating this. So I'm just gonna play a C on my bassoon. I'm also gonna sing that pitch with my beautiful voice. La. And you know what? Let's sing it with a different voice. Right, now we have the opportunity to see timbre. But what is timbre? When I was playing a moment ago, it sounded like I was producing a single note with my voice and with a bassoon. That note is what we refer to as the fundamental. In this case, the fundamental pitch is pretty quiet. Oh, my intonation was way off when I was singing. Timbre-wise, these all sound exactly the same. But we're not actually hearing just one note. We are hearing a whole harmonic series of notes. That is how we go from hearing just that fundamental to hearing a bassoon. So when we talk about timbre, what we're really referring to is the prevalence of different overtones within the sound that we hear. So here, if we look, this is the bassoon. You can see that The third harmonic is really quite strong. So is the eighth, seventh, eighth. Actually, just look around here, 4, 5, 6, see where those are, right? But if we go over to my singing, that third harmonic is a lot more suppressed. The fifth harmonic becomes a lot more prominent. If we look here at the fundamental pitch, well, we have a slight difference. So our fundamental pitch in all three of these is about the same. But if we look at the different overtones, we can see that they are wildly different from each other. And that is how we get a different timbre. In fact, the fundamental pitch is probably the least important part of the sound. If I filter that pitch out, it barely sounds any different. But if I start filtering out from the top, it really sounds different. If we filter down to just a few harmonics, just another demonstration here. Let's do the first 6 harmonics, okay? What does that sound like? It's definitely enough to hear a timbral difference, but this really doesn't sound very much like a bassoon yet. The bassoon really has a lot of harmonics within its sound. This here is a sort of visual representation of timbre. And I think this is really useful because we often will just listen to a timbre, whether we hear a note on a cello or an expensive cello or a bassoon, and say like, oh, I like that one. And that's fine. We like what we like for whatever reasons we like it. I wanted to be able to get some objective information about the differences in timbres, because sometimes we think we hear a big difference when we really don't. And I was really interested to see if I would find patterns in different harmonics or frequencies being more pronounced with different wire configurations. So this was an adventure. I come from a school of thought that timbre is a relatively low priority characteristic of a reed, that the most important aspects are its response and intonation. In fact, if a reed is truly responsive, I should be able to manipulate my timbre with how I play to a certain extent. I'm also inclined to think that the instrument and vocals I spent so much money on over others that were perfectly playable are really contributing more to my timbre than a whittled piece of grass. Your reeds are not going to make your bassoon sound like it costs $50,000 more than it actually does. Anyway, let me show you how I use software to help me analyze and discover differences in timbre among these wire configurations. The software helped me not only describe, but pick up on differences among the different wire configurations that I otherwise found quite vague and subtle. There's always a level of inconsistency when we perform a note because the initial tongue and the initial burst of air is going to have some effect on the pitch and timbral qualities. So I just cut those out. So then I would have just this one note and I could listen to just the middle of the pitch. So I could really analyze just the sort of real basic fundamental timbre that I was getting out of these different reed configurations. I don't feel like I'm hearing such an immediate standout. Maybe actually 3 stands out and maybe 5 stands out a little bit. Let's filter this and just listen to the uppers here. Pretty subtle, but I'm definitely hearing more in number 3, maybe number 5. This is for F sharp 2. Oh, wait a second. Here in the 5th configuration, this one point in time, the 6th harmonic is actually louder than 7 and 8. Oh no, it stays louder. It's actually also slightly louder on the 4th configuration, but everywhere else you can see the 6th harmonic is less. It looks like we found another harmonic that kind of sticks out in configuration 5. Is the 13th harmonic, at least on this reed. So we've got higher 6th harmonic, higher 13th harmonic. I'm looking at B flat 2 now. If we look up higher, configuration 1 seems pretty active above 4,000 hertz here, as well as 5. Looking at F3 on reed number 1, one thing that I think is interesting is configuration 1 and configuration 2. These are both yellow brass. The difference being that this was yellow brass that had been on the reed for who knows how long, and this is when I put on fresh yellow brass. So just seeing, I feel like I'm seeing it more in this note than previous notes so far, but I've certainly been seeing a difference. There's a pretty substantial difference between these two, between 1 and 2, and all that's changed or at least all that I intended to change, is older yellow brass for newer yellow brass. Does that explain every difference that I'm hearing? Probably not. Here we have F3 on reed 2. I feel like there's less difference between the notes here. There's still a difference. It's just less pronounced as I get towards the higher frequencies. Whereas before I could kind of skip around like this to try to get a good comparison of the representation here of each harmonic. The problem is that these harmonics are kind of wobbly. And the higher the pitch, the sort of more wobbling we have. So I really can't just like go and click at like one particular point in time. As I've gotten higher, I kind of have to scroll through and look for any tendencies. For instance, this configuration number 4, it's interesting. 7 seems to sometimes disappear within it, but it gets pretty loud too. Like 7 just seems really unstable for some reason. Whereas in these others, I mean, it's wobbling, but it never disappears, right? It's very, very easy with something so subjective as timbre to become biased and just start deciding that we like one better than the other, which is fine. You can like a sound just because you like it. You don't need a treatise to justify what your ear likes. But it helps to gain an understanding of why your ear might prefer something. I think even more importantly, to feel like there really is something to the differences that you're hearing, as opposed to just a sort of placebo effect. And then I can sort of re-ask myself, is that difference good? Is that difference worth X amount of effort? This all reminded me of those videos people often post comparing the sound of different instrument makers. I often find the comments on these videos especially amusing because so many people will chime in with such certainty about what they hear. Not just what is their preference, but what is actually better. Well, let me just out-snob the snobs here by saying these comments usually come down to brand loyalty rather than any actual insight on the qualities of sound. While there really was no clear winner or discernible patterns in which overtones would be emphasized that applied to all the notes I tested, some notes definitely had more variation among the different wire configurations than others. As I was trying to simply identify the differences between each configuration on a particular note, I really tried to avoid making value judgments over which notes I preferred. Nevertheless, in some cases my ear quickly found a favorite, while in other cases it did not. While I didn't find my preference between configurations changing when I compared the configurations on a second read, I did find that the strength of my preference did. In other words, the amount of difference between different configurations on a particular note varied, but not so much that I found the findings on one read completely contradicting the other. So what kind of timbre did I find myself preferring? For me, there are 2 words to describe it, and neither of those words are bright or dark. Instead, I'd have to say I liked tones that were complex and resonant. I'd like to think I produce a complex and resonant sound on all my reeds. This means that I like the sounds that seem to offer more overtones in general. However, in most cases, any reed that had more overtones in one region would probably have a little bit less in another. I'm finding in general, I'm starting to feel like I am seeing a bit more upper partials. Generally just, I'm often finding a bit more of something in reed configuration 5, but every once in a while there's something that I see less of. For instance, the 16th harmonic right here. You'll notice it's kind of suppressed here. Everywhere else, that 16th harmonic is really pronounced. So how can I define which overtones proved themselves to be the most important? That would be the ones that created the most resonance. Now, resonance is a word that musicians often throw around without defining. In this case, my definition of resonance is when overtones make a note sound louder without actually increasing its decibels. Or you could think of it as the perception of loudness without the actual increased energy of sound waves. One thing that I notice is that, at least when it goes back from 5 to 1, it sounds a lot softer. Now 1 is registering at about 11.7 decibels. 5 is negative 11, 5 is at negative. So they're very close. The actual volume here is very, very close. And in fact, the third one is quieter than all the others. If I'm looking at the decibels here, reed 5 should be the quietest, but if you listen to it, it doesn't really sound that way. Yeah, to me, 5 sounds loudest. 5 and 2. number 5 here, even though the decibels are a little bit lower than 1 through 3, it to me doesn't sound that way. After making this filter, I feel like in this case, part of why number 5 sounds louder, even though it's not, is because we have a stronger octave here, a stronger second harmonic, which would be the octave. It would essentially be D6. We've got D5 here, D6 here that are sounding. And because it's stronger there, it just sounds louder. Now, which configurations offered the most complex and resonant sound? That varied quite a bit from note to note, but it was most often configurations 1, 3, and 5, those being aged yellow brass, stainless steel and yellow brass, and stainless steel and red brass. The only noticeably deficient configuration was having all wires stainless steel. However, there were still 1 or 2 pitches that did the best with this configuration, and I do have to wonder how altering the scrape of that reed or the gauge of the wire might change this. So let's summarize what I found. In terms of ease of use, yellow brass wins. Yellow brass is easy to cut and flexible, unlike stainless steel. However, with an upgraded pair of pliers, I was able to close that gap substantially. Yellow brass also doesn't break as easily as red brass. Yellow brass is less expensive, though in reality that comes down to about 1 cent per reed, and I suppose in changing mineral markets that could change to about 2 or 3 cents per reed. In terms of coolness, stainless steel wins. While brass allergies are somewhat rare, I do appreciate that stainless steel is hypoallergenic and far less likely to contain lead than red or yellow brass. The wire doesn't really tarnish or stretch, and it stays shiny and rigid like a Spartan warrior. In terms of response, stainless steel loses. At least it loses when it's used for both the first and second wires. This was noticeable and clear on both reeds I tested, whereas the difference between the other materials and configurations was difficult to distinguish. The winner in terms of response was stainless steel on the second wire with red brass on the first wire by a hair. The difference was so slight, I'm not really convinced that this was because of the wire materials, but it seems like there may possibly be a slight advantage here. In terms of timbre, stainless steel on both wires once again loses. However, it's important to note that it actually won on a couple of notes in the tenor register. This certainly leaves open the possibility that stainless steel could prove to be a stronger candidate, perhaps with a tweaking of the scrape or gauge of the wire. But given how tedious and vague this whole process has been, I'm not going to be exploring this anytime soon. Ultimately, I felt like a stainless steel second wire and a red brass first wire offered a slight edge in terms of timbre, but I only analyzed 8 pitches across the instrument, and that was pretty exhausting. While I certainly felt like I was seeing a trend in objective data to justify my preference for this configuration, I can't deny that I was already slightly biased in having felt like this combination offered slightly improved response. The mere fact that this is a more unique wire combination also made me a little biased. Oh well. I would also like to think that all this effort led me to find some way to improve my reads. I'm pretty sure that if I wasn't so suspicious of my own internal biases, that I would be a lot more convinced that this new wire configuration was a genuine breakthrough in my reed making, offering a profound improvement to my craft. But instead, I find myself optimistic that I found a subtle improvement. Kind of makes you think about society in general, man, and internal biases, and our role as musicians to further our understanding and empathy for humanity. I can really feel the temptation that other bassoonists and reed makers must feel to tout a sense of conviction and a sort of scholarly confidence that their way is objectively advantageous. But because I've long been so skeptical when I sense this sort of arrogance and faux science in others, I resist. I do, however, feel confident that using these wire types is not a bad thing and that it warrants further exploration. Since doing this little experiment, I've made about 20 or 30 reeds with steel and red brass. We've got about another 40 in the works here. And I must say, I feel like they've turned out pretty well. I'm going to be curious to see how these reeds age and if I get any feedback from my customers on this change. Or perhaps some YouTube comments. So regardless of what wires you decide to use on your own reeds, I hope this has been a journey for you that has allowed you to further appreciate the complexities of bassoon reed making and the inevitable fallibility of traditional wisdom as it transcends the ages. If you find yourself feeling so appreciative, I hope you'll express that with your comments, likes, and subscribes. Happy practicing! Dude must be cray-cray. If one pushes resonance too far, won't that just make it harder to blend with the other instruments? Well, to that I say, cinnamon and sugar need to blend to make a tasty roll. And I may not exactly want to taste the sugar, but I damn well want to taste the cinnamon. And Bassoon ain't sugar. Bassoon is cinnamon.